guys, today is the third video of chapter 2. We're going to do units raised to a power and also density. Okay, so units raised to a power. We will have a conversion factor that's just a normal conversion factor. But when you have a unit like centimeters cubed from inches cubed, we know that 1 inch is equal to 2.54 centimeters. We do not know how many inches cubed are equal to how many centimeters cubed. So we have to also cube the whole conversion factor or raise it to that specific power. So here is our example. This one's going centimeters cubed to inches cubed. And notice they cubed everything, even the numbers. And when you do that, you're able to get the answer in inches cubed. So it wants us to get to meters. So I know there are 100 centimeters in 1 meter. So 2659 centimeters squared. I know centimeters goes on the bottom. So what I'm going to do is square this whole thing, actually. I'm just going to put squares on everything. So that's just the same as squaring everything. Now my centimeters squared cancel, and so do my centimeters squared from the bottom. Okay, do not square the original given. It is already in its squared unit. You're only squaring what you had the conversion factor from. Sorry, that doesn't change the number. 59 meters. Okay, sig figs are good because we only had 4 numbers and we've got 4 now. Remember, leading zeros don't count. Now we're doing inches to cubic centimeters. So I've got 289.7 inches cubed. I know in 1 inch is 2.54 centimeters. And again, my inches aren't right, so I've got to cube everything. And my inches cancel. So I do 289.7 times 2.54 cubed. And I get 4747 centimeters cubed, or cubic centimeters. All right, let's do another one. Decimeters to inches. So decimeter is a little different. That is 10 times smaller than centimeter. So in 1 decimeter, there's 10 centimeters. And then, so we have 15,615 decimeters cubed. So my decimeters cancel. I know I need to keep going because I don't have inches at the end. We got to cube everything because the units are cubed. Centimeters cubed cancels. So I've got 15,615 times 10 cubed divided by 2.54 cubed. And this is a pretty large number, but I need 5 sig figs. So I'm going to put it in scientific notation. So, or you could write 952,890 inches cubed. It did say where I have the 9, it had 8.5, so that's why I rounded it. And there it is. They also put it in the scientific notation. It's just easier that way. Okay, how many cubic inches are in a yard? So if you are unaware, there are 36 inches in a yard. So I've got 3.25 yards cubed. 1 yard is 36 inches. Make sure you cube everything. So I've got 3.25 times 36 cubed. I'm keeping 3 sig figs, so I have 152,000 inches cubed. Okay, this only works if all of them are the same exponent, or raised to the same power. So they put theirs in scientific notation, but it's the same number. All right, now we're going to move on to density. So density is mass divided by volume, and it just tells us how dense something is, how much mass there is, so stuff, per specific amount of volume. Okay, we will normally see them in either grams per centimeter cubed or grams per milliliter. This is the equation, mass over volume. While we're here, I do want you to write 1 centimeter cubed is equal to 1 cc is equal to 1 milliliter. So all of those units are the same thing. We normally use centimeters cubed for solids, and milliliters are for liquids, and then cc is just a cubic centimeter, which is the same as cm cubed. All right, so here they gave us a mass, they gave us a volume. We plug them in, and we get our answer. Notice, no units cancel here because they're not the same, so you keep both units. All right, so there's a lot going on here. I have 5.84. I've got 0.556 centimeters cubed. It tells me the density is this, and then it's got a lot more. It wants to know, is the ring platinum? And the density of platinum is this. So first, I need to find density. So 5.84 grams divided by 0.556 centimeters cubed. Notice, it says the ring displaces this much volume. That means when you put it in a graduated cylinder of water, the water changes by 0.556 centimeters. So I get that the density of this is 10.5. So then you say, is the ring platinum? No, that density does not match. The density of elements and compounds are constants. They're the same regardless. So often, jewelers and stuff can find if something is real gold or real silver based on the density. Okay, now it says, I think it still wants to know if it was platinum, and I think it was like 21.6, something like that. So let's see, our density here is 9.67 divided by 0.452. That one's better, 21.4. Okay, I bet that's what this should have been, 0.4. Okay, let me go back and check. Yeah, 21.4. I wrote it wrong. So this ring is platinum because the densities match. Okay, sometimes we can also use density as a conversion factor because it's got those two different units. So it makes it easy to use as a conversion factor. So here we want to know what volume should be measured if we have 68.4 grams. I do want to note there are two givens here. But the one with 2 units is a conversion factor. Something to note, the number goes with the top unit. So we're doing 68.4 divided by 1.32. And I get 51.8. And that's centimeters cubed. And then because it says it's a liquid, I'm going to say 51.8 milliliters. Okay, so here's a common density table. Mastering Chemistry, your homework program, may have a question that asks you, is this the ethanol? Or it may ask you, or not give you a density because they're on this table. So I would just make note of this. On any quiz or test, I will give it to you. Okay, so we've got 60 kilograms. They gave us a density and they want to know the volume. So I've got 60 kilograms. I got to get kilograms to grams, so a kilogram is 1,000 grams. And then I've got my grams per centimeter cubed. Again, 1 goes with the bottom unit. So I do 60 times 1,000 divided by 0.752. So the volume of this gas tank is 79800 centimeters cubed, which is pretty big. Normally we would probably measure this in liters, and if we did that, it'd be 79.8 liters, which is much more of a reasonable number. Okay, oh well, this one already gave you the answer. It's the same process, but you're getting milligrams to grams instead of kilograms to grams. So just know, again, there's 1,000 milli in one base unit, which is the one that doesn't have a prefix. Okay, one more. What is the mass in kilograms? So this one's a little different. I'm starting with centimeters cubed. Centimeters cubed goes on the bottom, but notice it's already there, so I don't have to cube this. And this one does ask for kilograms, so you've got to do the conversion. So I've got 246 times 7.93 divided by 1,000, and I get 1.95 kilograms of steel. Well, that's how much mass can fit in there. All right, and that is it. This is the rest of this is a review. You're more than welcome to look at it. These are all the things you should know, along with all the things I stressed through the videos. So please let me know if y'all have any questions. Y'all have a good rest of your day.